problem 5. Are you in this group?
Yes.
Yes, I have not done it, but I have the
Don't worry about it. Okay.
but I have the solution from last year.
Okay.
Where you can find it. So I'm sharing my screen. Can you see?
Yeah.
If you go on my web page. In the teaching section, or it is. And you go to the notes for constraint optimization 1 year ago. So that exercise is basically the exercise 12.19, and it's here.
Hi, Adam. Which one is this one?
So this is the exercise 5 from optimization.
All right. Okay, thanks.
Sure. And you don't have to do the last point because you have not seen the second order necessary sufficient condition for optimality with Agus. So we just first 2 points. Okay.
Would you be able to share this with us, or is it posted somewhere?
It's here. So those are the notes from 1 year ago for constraint.
Oh yeah, I will find that. I'll find that. No problem.
Sure.
Thanks.
Okay, so let's do like this. Who is ready? Just write a comment in the chat. And then when everybody's ready, we can discuss it together. Okay? Okay, so I see 1, 2, 3, 4, 5, 6, and we are in 9. So 8 without me. Am I counting well? So 2 missing. Okay, let's wait a little bit more.
Adam? Adam? Adam?
Yes, sorry.
Can you give a hint how to put it on quadratic form? Because I can't get to see where the square comes from.
Which one?
In
Me
number
neither.
4.
Say it again.
In number 4, I can't really see where the square comes from and how we should put it in quadratic form.
So basically you have the matrix H, right?
Yes. No, we need to create matrix H, but I don't get to see how we can get the quadratic form. Like, I don't have any x squares.
To me, it looks like two independent linear optimization problems.
But you know that you get 3 minus 0.4 x1 profit per x1.
What?
Okay, so you want to maximize the profit,
Yes.
Oh, yes.
and you have to multiply the profit stated for x1 by the amount of x1 you produce. That's where you get the square.
But isn't x the production of A?
So like this.
So to understand is that this is stating that when the production increase, the term in the profit decrease, but it increase with the outer term. That doesn't really make sense from the formulation.
Yeah. So like the more you produce, the less the profit. Yeah.
Because from this is stating below that where x1 is the production of the product. But I can see because it says the pair word afterwards.
Yeah, since it's minus 0.4 x1, which means if we increase the x1, I mean, if we decrease the x1 or x2, then we increase the profit, right?
No, because you have to take the negative to it.
Okay. Adam? Hi, Adam.
Yes.
So it's 3 minus 0.4 x1 times x1 and the addition of the next one. That is a quadratic equation, right?
Exactly.
But what about the constraints? We are given constraints in terms of the reactor
Yeah,
hours. How do we define that in terms of x1 and x2?
that's correct. So basically, it says the profit is the thing. Okay, just give me a sec. So it's about the availability, right?
Yes, availability, right?
So it says, for instance, for the first one, that 2x1 plus
Okay.
x2 has to be less equal to 2. Do you have the idea now?
I have got some idea because 1000 kg of air, we have to convert that into tons. Oh, that is 1 ton, 1000 kg. Okay. Okay. I'll look into it.
Sure.
Yeah.
But how can you use x1 in the statement? Because if you use x1 in both the constraints, then they are scaling with each other, and they are not supposed to do that.
Was it for me, the question?
Yes, for you.
Can you say it again? Sorry.
So you said we have to use x1 in the constraint for the hours, but if we do that, then we scale both constraints with x1.
Is it a problem?
Yeah, because then the production time on one of them is
Yeah,
is
but
also increasing the production in the other one, and that doesn't really make sense.
why does not make sense? So it says basically R1 and R2 are available for 8 and 15 hours respectively. So you have AND, which means that you have linear systems of them, right? I don't see the point.
Ah, I didn't see the and. I thought it was all.
Yeah.
Okay, that makes sense.
Adam, hello.
Yes, hello.
Yes, Adam. Can you tell me what the constraints are?
Sure. So everybody's ready for the constraints? So first of all, you have to have the decision variable greater or equal to 0 for both the decision variables. So those are two constraints.
Yes, 8 and 15.
And then you have the first one, which is minus 2x1 minus x2 greater or equal to minus 8, which is the first one, right? Because it asks that it has to be available for 8 hours. And the second one is minus x1, right?
Minus x1 minus x2 greater less than equal to 8.
That was the first one.
Yeah.
I will write it down.
Wow.
Okay, you all agree on this?
Yeah.
And the
Minus
second,
2x1.
the second statement in the initial problem, which was, let me check, and 15 hours. Yes. Right? Everybody reached this solution in the constraints?
Yes.
And then you have the two for the decision variables in order to be feasible, right?
Yeah.
Adam?
Yes.
I might have misunderstood the exercise, but are we supposed to look at each reactor as an independent problem?
Why you think so?
I can't see how I can't see how they're interlinked. Like, do they depend on each other in some way?
They do.
How?
So basically you are saying reactors R1 and R2, and then the constraint is the order of R1 and R2, right? So basically you don't care in which order they are going, but you care about their availability together. And we want to maximize the profits out of them, so they are linked together.
Order does not matter.
I mean, you could see it without the reactors, and you can put anything in it, and it's the same kind of problem still. So imagine it like, I don't know, a production process 1 and process 2. If reactors are the misleading factor in this exercise. Are you still confused, or it's better?
Kind of, yeah.
Adam, do you have the solution for exercise 4?
I do.
Just so I can check it if it's correct.
Yeah, sure. I was just waiting that everybody's ready for the solution so we can discuss it. So the constraints are those that I wrote in the chat. And if there is anybody adventurous enough to write the H and F transpose function, sorry, matrix and vector, so we can see if it's the same for all of us. Anybody?
Just a question, why do you put the inequality sign as greater than when the form in MATLAB says it has to be less than?
You can do the same, you just invert it. It's just that I'm using my function and my function needs it in the standard form, which is this one. So.
Okay.
Should I just write the HNF?
Yes. That's correct. Okay, so everybody has this solution? Yes, no, maybe?
Is this for number 4?
Yes, this is number 4.
No, I don't have that. I have, but are we supposed to multiply by 2 for?
Just share, please, your solution.
Yeah, but shouldn't you multiply the diagonal with 2 because you have the half before that?
Yeah. And my F came to be 3 and 2.
Yes, sorry, I'm wrong. It's not that. It's 0.8, the 1, 1,
Yeah.
and 0.4, the 2, 2. Yeah, sorry guys, I'm basically switching from one group to the other, so.
It's
No
okay.
problem.
Okay, so this is the 4th, and the correct one, I just write it, so we have it for reference, 0.8. 0.4. Yes, so this is the H. Anybody solution for the second and the third exercise?
Add-on, when we like the quadratic function,
Mm-hmm.
I found the quadratic function to be 3x1 minus 0.4x1 square, and forwarding. So if we put that function into matrix form, I get 2 times minus 0.4. I mean inside the G. I mean it comes negative diagonals. Is it like
Yes, but you're writing the so basically here you are doing the minimum of the negative of the profit, right?
yes.
Which means that it's positive. Then you change it in negative.
Oh, we have to multiply the equation by -1.
Exactly.
Okay.
So that's why you have the F that is negative and the H that is positive, right? Because we have multiplied by -1.
Now it's clear.
Okay, perfect. So 4 is clear for everybody, right? Yes, nobody's objecting, so I think so. Then exercise 3. Anybody wants to write the solution?
Can we have the solution for exercise 4?
I was thinking the same.
I did not put it in MATLAB yet, but you just put in MATLAB the HNF and solve it, and it gives you the solution. So I don't think there is anything up there. And then the exercise asks to write the program in the quadratic form, which we did. So
Just to check, I get this so then everyone can say what they if they get the same.
Yeah, I get that too.
Okay, good.
you have to write it in the solver.
No, I'm not getting the result. It's not accurate. I'm not getting an accurate answer out of it. So G is 0.8, 0, 0, and 0.4, right, Adam? Yeah, you gave that.
Yeah, 0.
C is, yeah. C is -3 and -2. Then A is 2, 1, 1, 3.
2, 1, 1, 3.
Yes, that's the same.
Because I multiplied that with -1 so that it satisfies the AX less than. Okay. I perhaps have not.
Who is using MATLAB? Can anybody check this? Because I'm not using MATLAB with this one, so.
Well, I'm also getting the result as Soren has.
Me too.
And can you share with us the code, please?
I just sent it in the chat.
Why are we taking the that in the A matrix, the rest of the code matrices in the third and fourth row?
That's the lower bound constraint.
That's the lowers.
Lower bound.
Okay, lower bound.
It's instead of using the lower bound variable.
And in the A matrix where we have -1, 0, and 0, -1 in the third and fourth row.
What?
Why are we taking the third and fourth row in the A matrix?
That's to implement the lower bound constraint.
It's instead of using the lower bound constraint in the quadratic programming function.
Okay, thank you.
Let's try the third exercise. What's the solution for the third?
So, do you guys know why we should implement in MATLAB lesser than instead of bigger than?
That's because that's how they've defined the function in the datasheet.
Yeah, okay, sure. But it's just that the KKT condition is bigger than. But,
Yeah,
yeah.
but that's just their definition.
Ah, okay.
Okay, so my solution for the third one is.
Adam, you are very hard to hear.
Fine.
You are very low voice.
I have no idea what's going on. Is this better?
Yeah.
On.
Okay. So the third exercise, anybody wants to write the solution? Or I can do it?
2 sec. I get 1 and 1.
Me too.
Me too.
Yeah, same here.
Me too. Good.
Yeah.
And then the exercise 2.
Yeah.
Yes.
Yeah.
Yep.
Okay. Adam,
Yes.
I was wondering if we had time to talk about the assignment.
Sure,
Maybe.
we do.
Should we do that now or later? Or?
We can do it now.
Okay. It's the linear programming problem.
Let me see.
So it's problem 12.
I'm listening.
Yeah, but we are a couple of guys who have quite a bit of trouble with that problem.
Yes.
Yeah, I guess we don't really know how to set it up with because from the problem it says that the demand is 75 units of the red brick. So I guess that imposes an inequality constraint that x1 has to be above 45. Or
I still need to look into it in detail, to be honest.
yeah.
Just give me a sec.
Yeah.
I see there's an equality constraint.
Yeah.
Because you want to max equality, not inequality, because you want to maximize the sum of loads of the bricks, right? In the rows.
Yeah. So is it okay that I post what I have written right now?
I think so.
Yeah, I can just post it here. So I've written that we want to maximize x1 plus x2. And then we have the inequality constraints from the amount of hours it takes to, or minutes it takes to produce the bricks.
I'm not sure about that one, actually.
Okay.
I have the same. I think it makes sense.
Where does the 45 comes from?
It's that we have 30 red bricks at the start of the week, and then it's forecasted that we need 75 units during the week. So we need to produce 45 just to keep up with the demand.
I see, but why it's an inequality? Because it does not say anything. Give me a sec to read it again.
Because if we need to produce that amount, then x have to be greater than that in order for us to reach the demand. Because the text says that the demand is forecast to be 75 and you have 95 units in stock.
Yeah, I see. Because you have lower equal and then greater equal. And it might make sense. I must be honest that I have not looked that much into the problem. So I don't have the solution on hand to tell you if it's correct or not. It might make sense actually. Have you tried to put it in MATLAB or anything? Does it give a reasonable solution? Looking at it right now, it might give a reasonable solution, so it might be correct. Have you?
No, I have not tried yet.
Well, I have tried, but it doesn't make sense the solution it gives. Well,
Okay.
not in my case. And I think I have done the same thing as Emil.
I'm guessing it. Yeah. I'm guessing the first one should be inequality. Yes. Yes, I think so. Don't use the lower equal, but then equal the. Because you want to maximize it, right?
Yeah.
Otherwise, if you use lower equal, you get the whole space. So it will just give you the first solution that it finds.
Okay, so we have to use equal to.
If you want to maximize it.
Yeah, okay.
Otherwise, you get the region
Yeah.
solutions. It
Yeah.
doesn't.
But how about the constraints on x1 and x2?
They look reasonable.
Yeah.
If you're speaking about the inequality constraints, yeah.
So you're saying what should be equality constraint and what should be inequality constraint?
I'm saying that 2400 should be equality constraint because you want to maximize those two.
Okay.
I do agree more on this. Although I have not tried the solution, I'm trying right now. So.
Yeah, so when we have the equality constraint, we have two variables with two equations. And if, for my part, if I solve it and get x1 and x2, it doesn't comply with the what is called the inequality constraint. I only get one solution pair.
But do we have to use the select variables procedure?
Oh yeah, I haven't done that.
Is there a workaround?
Well, I mean, I tried. It might be that the problem does not give a solution, and then it does not have a solution. It happens. But first of all, I would define that in the matrix vector notation.
But I also have a question.
Sure.
I'm just going to write it quickly. Yeah, so if we just comply with the inequality constraints and say that, for example, x1 equals to 45 and x2 equals to 5, then the amount of time we use in the simple coloring scheme, that's already 2,370. So there's only 30 minutes left, and then we can only produce 1 euro brick more. So it's like that. It's the constraints. Yeah, there's only one solution. And
Then if it results like this, you can tell that the equality constraint is not met, so that's not the solution. So the only solution that you found is not the solution and the problem is intractable. Which might make sense. I am trying to solve it right now to see
Okay.
if it's that the case. Yeah, so reading better, I'm not sure about the equality constraint actually. I think you were right with the minor equal in the equality constraints, but then I get a different solution from yours. A solution that is very close to yours, but it's not the same.
Okay.
And then if you try to put that one inside, back. Let me check. I get the solution also with the equality, so it shouldn't matter that much if you're using equality or inequality. To be consistent with the problem definition that you have the equality constraint, I would go for the equality.
Okay.
And then the solution is slightly different, but you can guess the solution by doing just the intersection between the equality constraint and the cost function, which is rather simple. So.
But how do you incorporate the inequality constraint for with the x1 and x2?
So for the x1, it's just 75 minus 30, right?
Yeah, but I mean, like in the KKT conditions, because I can only find KKT conditions where they only use equality constraints.
Then you can use the fifth one, right? And you can put your equality there.
Okay.
Which then be when those two are equal to 0, I guess. Yes. I guess so. Yeah. Yeah, so basically you would use the second one on your equality constraints. Okay, guys, any other question? Also on the assignment, just feel free to ask.
I think we're only missing the linear programming one. I don't know about.
You just try to solve it, and then everybody's having a problem with it, and you cannot solve it, then I can help you.
Okay, so the conclusion to the one we just talked about is what? That it is unsolvable, or?
I think it has a solution.
Okay.
I have to sit on it and look into it for reasonably long to be sure that that one is the solution, but I just found the solution. This is very close to the solution that you post, by the way. But it's not that one.
Okay.
X1 is correct, X2 is not.
But
Did you get
X2
X2
can't
to
be anything
5?
else, can it?
Sorry?
X2 can't really be anything else without the conditions being false, unless it's a decimal number.
I got something that is not that one, and it's correct, and it's a decimal number, yes.
But can you produce like half loads of bricks?
Well, if a lot of bricks contain a number of bricks, you can just use half of them, a quarter.
Yes.
I mean, it's not the number of humans, so it really doesn't matter if you divide it.
So I don't know. How do we put this on the standard form when we have inequality constraints?
But this is an equality constraint then. You see, 50x1 plus 24x2 equal to 2400.
Yeah, but I was thinking about we have an inequality constraint from the x1 has to be above 45.
Mm-hmm.
How do we get that into the standard form?
So basically that would be not greater or equal to 0, so the 0 vector.
Yeah.
0 vector, right? But you will get a vector 45, 6.
Okay, so we can just
Yeah, I mean, it's greater at the constant.
okay, so that's all. That's okay, or what? To have that?
I'm thinking I never used that one in MATLAB, to be honest, so I don't know if MATLAB has only zeros as possibility to input it.
Yeah, it's just in the book they say that the standard form is that x is above or equal to 0.
Yeah, simplified. Actually, it's even not correct because it should be 0 vector and x should be a vector as well.
Yeah, okay.
But basically, they're using the same theory for economy, so they need to simplify it to understand it. I hope there is nobody from economy here. Sorry.
So we are not supposed to convert it to this form.
Which one?
I have it here, like this one. Yeah.
Not really, I don't see any reason why. You could, if you're
Well,
feeling doing so.
No.
So we should just set the unequal constraint to an equal constraint with the equal to 45.
Say it again, you should constrain an equal constraint to an equal constraint?
No, okay, so in the text we have, just gonna, so we have this given from that we need the difference between the stock and the what we demand, which is the 45, which is an unequal constraint. So how do you say we can contain that into the A matrix?
But that does not go into the A matrix. You have the equality constraints into the A matrix. This
Then
is the
what-
inequality constraint.
But where does it go in our standard form if we don't need to introduce a slack variable?
This is the standard form. And then you will have, I don't know, x tilde, x dot, x whatsoever. So let's call it z1, z1, and z2. Which will be then equal to your decision variable under the constraint. So x1 minus 45, x2 minus 5. And then the standard form will be
Okay, yeah, I think I understand.
Okay.
so basically you're just watching what happens to your decision variable 45 above, 45 below, and 5 below on the x-axis and on the y-axis, which is still completely valid. I don't see any problem with it. Right? Are you following me?
So like this, or I don't know.
Mm-hmm. I agree on the constraints. Yes.
Okay.
Okay, guys, so I have the second group.
Yeah.
Any other quick question?
Not right now.
No, not for my part.
Just write me an email if you need anything also about the assignment.
Very
I try
nice.
to be quick. Thanks.
Great.
See you.
Thank you. See you.
Bye.
Bye.
Bye. Oh, guys.
Så hvad, vi skal erstatte x?
Ja, så vi skal ikke bruge... Vi får lov til at skrive om i standardform, men
Hvad fanden er det for noget pis?
så er det jo ikke standardformen.
Det har vi da ikke lært heller.
Ja, så er det godt, jeg kom til at mute ham der, Imran.
Ja, det forstår jeg godt. Der var meget baggrundsstøj ved ham.
Jamen, mutede jeg ham op for jer?
Nej. Så kun det er hosten og opkaldt, der kan gøre det.
Så det er fordi, jeg kunne også smide ham ud af opkaldet.
Ja.
Nice.
Ja, men
Og det kan jeg sgu da også med dig.
ja, det er det, så jeg tror sgu, jeg muter ham for alle.
Kan vi høre Søren nu?
Nej. Søren, unmute dig selv igen. Søren, du skal unmute dig selv.
Hvad fanden er det for noget OP shit, man kan?
Ej, så har jeg bare mutet ham for alle.
Så man kan smide folk ud og mute?
Ej, så har han bare siddet der først og blevet muted.
Oh my god, Emil.
Sådan der. Så er Emil væk.
For helvede. Det var ikke mig, der mutede.
Det er Jørgen nu.
Ja.
Okay, det er godt.
Oh my goodness.
Nå, okay. Så status er hvad?
Vi skal skrive det her op.
Men vil det sige, at vi skal bruge x tilde i alle så?
Nej.
Nej.
Kun i den der.
Kun i hvad?
Det der billede, jeg sendte, det sagde han, at det så rigtigt ud.
Jo, men vi skal vel bruge x tilde så i alle KKT'erne efterfølgende.
Jeg tror kun, vi skal bruge x tilde i større end lige med 0.
Ja.
Fordi at C'eren, det er for inequality.
Ja.
Jamen hvad så? Altså, så kommer vi jo stadigvæk ud i det samme problem, det her.
Nej, fordi nu har du så et x tilde skal være større end lig 0.
Det der.
Er det et problem?
Men hvis du løser for den her, så er der kun én